So welcome to AWS DevOps section, guys. Okay. So any idea anywhere? I mean, earlier you heard about this DevOps. Any idea? So DevOps. So if you split these two words, DevOps. Okay. So Dev stands for development, and Ops stands for operations. And recently we have added SCSEC. That means security. So earlier, so the DevOps guys used to handle the development plus operations. Along with that, now we are handling the security as well, guys. Okay. So that is the DevSecOps. So what is a DevOps then? Okay, so which are all those two teams works together? That is development, the developer and operations team. So these two teams collaborative works together is called as a DevOps guys. Okay, so whether it is a new tool here, okay, so DevOps is not a new tool here. It's a new strategy develop any of the software product. Is the DevOps is a new technology? No, guys. So DevOps is not a new technology here. It is a new strategy to develop any of the software product here. Okay. Most of the tools used in the DevOps are open source. That means we no need to purchase a license here in order to use those software. Okay. And most importantly, deployment is automated. So what is a DevOps here? So the two teams, that is the development plus operations team. So these two teams collaboratively works together is called as a DevOps guys. Okay. So is it a DevOps is a new technology here? No, DevOps is not a new technology here. It's a new strategy to develop any of the software product guys. Okay. And most of the tools used in this DevOps are open source. That means it is a freely available softwares. We no need to purchase any license in order to use those softwares here. Okay. And most importantly, the deployment is automated here. Okay. So let's see how we can achieve this automation via DevOps. I have a one developer. So developer A, developers B here, and developer C here. Okay. So during a real time, what happens, guys? So these developers will be working in terms of modules. Okay, that is a module A, module B, and module C here. Okay. Let's say assume. So this is a developer A and developer B and developer C here. Okay. Now assume. So this developer A requires the code wrote by this developer C here. Okay. How he will interact here, right? So during a real time, we will be not knowing who is this developer here, who is this developer B or developer C here. Okay. And even if we are aware also via any of the communication media here, okay, either a WhatsApp or your official Teams chat and the mail also. Okay. We are not supposed to do such activities. Okay. If we make like that, then you will be fired. So then what is the solution then? So what we will do? So we will be using a one VCS here. Okay, VCS stands for version control system, VCS. Okay. Okay. So now what this developer will do is, so this developer will start whatever the code they have wrote, they will start pushing that code to this VCS. That is the version control system. This is the one of the central tool. Okay, like this. Okay. Now, if the developer requires a code wrote by this developer C, he no need to check with this developer C here. Okay, he will check with this version control system. Okay, if that code is available, he will pull to his local machine and he will start updating that code, guys. So now we have a VCS, that is a, I mean, we have got a code that is a raw source code, guys. Raw source code in the sense this code is not a executable code here. Okay, sorry, one second. Before that, let me make a note of this. Okay, VCS stands for version control system. Okay. Example for this is subversion, okay, EFS, etc. Okay. Now this is the raw source code, guys. Okay. Using this raw source code, we cannot deploy this application to our target servers here or our application servers here. That means this is just the ingredients here. This is not a food here to have. Okay. So what we need to do is using this raw source code, we have to make the code as a executable code, guys. Okay. So for that, we will be using a one of the build tool. Okay. Example for this is so Ant, Maven, and Gradle. Okay. So what this build tool will do is using any one of this build tool, either Ant, either Maven or Gradle, we will create an artifact here. Okay. Let's say if you are working for a Java project, then the artifacts will be like a .jar. Okay, that means jar stands for Java archives. Okay, then var stands for web archives. Okay. Then dot EAR stands for enterprise archives. So using any one of this build tool, either Ant or Maven or Gradle, okay, any one of this build tool, we will create these kind of artifacts for a Java here. Okay. Let's say if you're working for a .NET, okay, or a C Sharp, okay, then we will be using the build tool, something called as a MS build. Okay, that is a Microsoft build. And the artifact will be like a .zip here. Okay, right now in a Java, you can see it is .jar or var. So for a .NET project, our build tool will be MS build. That is a Microsoft build. And the artifacts will be like a .zip here. Okay, let's go back now. Okay, as we have three developers here. Okay, so some might be the intelligent developer guys, and some might be the core developer here, right? Since the organization they want to maintain the standard of their source code, okay, we will be using the code quality checking tool. That is a Sonar Cube. Okay, example for this is Sonar Cube. Okay, so what this Sonar Cube will do is, so it is going to scan your entire source code wrote by this developer. Okay, and it generates a report. Okay, based on the quality of the source code, being a DevOps engineer, we will decide whether we can push this code to the further development or no. Okay, now comes the one of the other important tool, that is the Artifactory repository. Okay, why we need to use the Artifactory repo, guys? Okay, so basically, today I have done one of the deployment to the production server. Okay, assume that that newly deployed artifact is having some issue. Okay, I want to do the rollback. Okay, when I'm doing the rollback, so I need the previous version of the artifact here, right? Okay, so for that we will be using this Artifactory repository. Example for this is Nexus or JFrog. So now comes our important tool, that is a CI tool. CI stands for continuous integration. As the name suggests here, continuous integration, that means we are integrating all those tools with our CI tool. Example for this is Jenkins. Okay, then Hudson, Hudson, then Bamboo, and many more guys in the market. Okay, like Azure DevOps. Okay, and AWS CodeCommit is there. Okay. Like that, many more. Okay. Whichever the tool we are flexible. Okay. So now what we will do, as a name suggests here, continuous integration. That means we are going to integrate. Okay. So now I have integrated all my tool with a CI tool. Okay. Let's take an example of Jenkins only. So once I integrate here, so what this Jenkins will do will, it will automatically connects to this VCS, that is a version control system, and gets the raw source code. Okay. And once it got a raw source code, it will push that code to a source code quality checking tool. Okay, for a Sonar Cube, in order to scan the entire source code and generate a report. Okay, if the quality of the source code is up to the mark, then this Jenkins will automatically pushes that code to the build tool in order to create an artifact. That means in order to make the raw source code to an executable code here. Okay, so once after that artifact has been generated, in order to keep backup of these generated artifact, we are publishing that artifact to our Artifactory repository, that is to our Nexus or a JFrog, guys. Okay, now till here everything looks good. Now I have an artifact, a code is done, everything is perfect. Now I can perform the deployment here. Okay, so for a deployment I can use say Tomcat or a Wildfly server here. Okay, so again, what I need to do, I need to integrate this to our Jenkins here in order to deploy the application to my target server here like this. Okay, so this architecture works fine. Okay, if it is a simple application. Okay, so during a real time, what happens, guys? In order to maintain the high availability, we will be deploying this application in a multiple servers. Okay, like this. I'm just taking an example of three application servers. So do I need to create a three jobs here for these three servers? We can do that, but it is not a recommended way, guys. Okay. So for that, what we will do, we will use one of the intermediate tool here, that is the configuration management tool. Okay. So example for this configuration management tool is Ansible, Chef, or Puppet. Okay. So now what we will do, we will integrate this Ansible with our Jenkins, guys. Okay. So once we integrate with our Ansible with our configuration management tool, okay, we will be using Ansible, guys. Okay, 𝗧𝗿𝗶𝗶𝗶 is the outdated one. Okay. So we will write a playbook here. Okay. Using this playbook, we will perform the deployment to a target server in a single shot, pushing the artifact simultaneously to all the three servers, guys, here. Okay, like this, right? So now everything looks good, right? Okay. So since most of the organization now they're working on a microservice architecture, that is the one function for one service. Okay. So let's say when you log into Amazon here, okay, Amazon.in, here you will see n number of other things here, right? So here delivery is there, return is there, cart is there. So what it is going to do is it is having the internally some of the service it is running, guys. Okay. So what we will do, we will be using the containerization tool. As the name suggests here, containerization. That means we are containerizing all the application, okay, in one single image here, okay. And most importantly, the size of this image will be very less. Okay. So if I want to give an example for this containerization, if you might have saw shifting your house from one location to another location. So what you guys will do is you are going to hire a one vendor. So he is going to bring some vehicle and putting all your utensils, TV, fridge, etc. Okay. He is going to dump all those things in one of the vehicle and he is shifting from one location to another location here. Okay. So similarly here also in a Docker, so here we'll be having our operating system with any other dependency, any of the environment variables. Okay. So all those things we will make it in a one isolated container image here. Okay. So from that image, we will be using the container. Okay. So that is one of the example for this Docker, guys. That is containerizing the application. Or else one more example I can give you. Let's say being a developer, I can say because of my system configuration or something, okay, whatever the code I wrote, it will be working fine in my local machine. But the same when I deploy to the any of the target server, okay, either to a dev or SIT or replica or production might work fine or it might misbehave because of my system configuration or any dependency file or any environment file, right? So in order to overcome this issue, Docker comes into the picture. Okay. If the Docker application is working fine in my local machine, the same behavior we can expect in any of the operating system, guys. Either in Windows, or either in Linux, either in a Mac OS. Okay, it behaves same thing. Okay, so that is one of the other example, guys.
Arjun,
Yes. Yeah.
Arjun, can you please compare it with the monolithic application that we were using previously, nearly 10 years back? With this one, we are using Docker because at that point of time in the monolithic application, we were trying to deploy and we were not having any Jenkins or any kind of these containerization tools. So what have we changed from monolithic to this microservice architecture? So if you can briefly explain that, that would be really helpful.
Okay, one example I can give with monolithic and microservice architecture.
What was the need exactly so that we moved from the monolithic to here? Because that would be really helpful.
So take an example of this Amazon.in only. So as it is a web application, so earlier days they will be deploying, creating the web application. Okay. Let's say during the big billion day or something, they want to advertise something, right? So at that time, what we used to do is we need to take the entire application down, guys. Okay, in a monolith architecture, we need to take the entire application down. Sometimes the end users we cannot able to access our application. Okay, but right now using the microservice architecture, okay, as you can see here, let's say this Amazon.in. Let's say I want to change this delivery address here. Okay, like right now it's sort of something is there. Okay, right. I want to update something on this delivery service. Okay, at that time, what we will do is in the backend, when I take the delivery service down, rest of the my entire application will be working fine. That means I'm achieving the high availability of my application. That is 24/7. My application will be working fine. End users can able to connect to my service here, right? And since it is available 24/7, it will not impact on my business. My users will be always be connected to me. And whatever they want, they can perform here. Okay. Is that fine? That was one of the major update I can say. But even there is a drawback also, the microservice architecture, because for developing one application, we'll be having around 10 to 15 services. Okay. But whereas in a monolithic one, only one var file in your entire service will be up and running. Okay. So always there is a pros and cons with all the applications. Okay. Whether it is a monolithic or a microservice architecture. Okay. I
Okay.
hope I answered your query.
Yeah, yeah. Streamline that particular thing or whatever you want to see, we use containerization.
Absolutely. In order to maintain the high availability, we are using this microservice architecture. And most
Yeah.
importantly, earlier what happens here is, as it take an example of this one only, these three servers is there, right? In a monolithic, one application will be deployed in one server only. Whether that application is utilizing this entire resource or no. Resource in the sense, let's say it is having a 3 CPU or 4 CPU, along with that 16 to 32 GB of RAM, right? Whether it is utilizing or no, we are just reserving for it. Okay, but using the microservice architecture, what happens here is in this server, I can deploy multiple applications here. Monolithic, in one service, I can deploy only one application. Whereas in the microservice architecture, in one single server, I can run multiple applications. Isn't it cool? And I'm not going to reserve any resources there. Or else it is one of the best example. It is a substitute for the VMware virtual machine. Anybody remember VMware? VMware workstation in 10 years back, it was there. Multiple operating system. When we want to have a multiple operating system in the same machine, at that time we were using this VMware workstation. Like that, I mean, let's take an example on this. Mine is a Windows 11 machine. Yeah. So let's say I want a Linux box in this Windows one. So how can I do that? Okay. So we will be using this VMware workstation. I used to install again Linux operating system there. So it is actually the substitute for that VMware. Take an example of this Amazon.in only. So being a human, every time I cannot come and see here whether my application is working fine or no. Okay. So for that, what I will be doing is we will be using any one of the monitoring tool. So example for this monitoring tools are like Grafana, okay, Prometheus and Nagios. Okay, Azure Monitor, a number of tools are here, guys. Okay, right. So using this, any one of the monitoring tool, okay, we will be having a supporting team member. Like if you might have heard about this L1 support, L2 support, guys. Okay, if anything goes wrong, guys. Okay, so this monitoring tool will send a notification to this supporting team member. Take an example of L1 support or L2 support. Okay, so using any one of these ticketing tool. For example is ServiceNow, okay, or Jira, Service Desk, anything else, okay. So using any one of this ticketing tool, this supporting team member will raise a ticket, okay. If anything wrong with the infrastructure, then he is going to raise a ticket to our DevOps engineer, guys. So this entire process is called as a CI/CD process, guys. Okay, CI/CD, that continuous integration and continuous delivery. Okay, so let's recall one by one. Okay, so assume we have a three developers, guys. Okay, developer A, developer B, and developer C here. Okay, so these developer will push us the code to the version control system. Okay, so once after that, what we need to do, we need to create a one job in a Jenkins. Okay, so later, so this Jenkins will automatically connects to the VCS, that is a version control system, and fetches the raw source code. Okay, so once it got a raw source code, it sends the code to the source code quality checking tool, that is a SonarQube. Okay, in order to check the quality of the source code. If the quality of the source code is are up to the mark, then Jenkins will automatically push us to the build tool. Okay, like example, Ant or Maven or Gradle. Using any one of this build tool, it is going to generate a this kind of artifacts, guys, like jar, var, or EAR. So jar stands for Java Archives, var stands for Web Archives, and EAR stands for Enterprise Archives here. Okay. So once the artifact has been generated, we are publishing that artifact to our Artifactory repository. That is our Nexus or JFrog, guys. Okay. So once this artifact has been created and we are uploaded or saved our artifact, generated artifact, we are publishing that artifact to our configuration management tool. Okay. That is Ansible in this case. Okay. So using this Ansible, we are pushing the code to the application servers, that is our Tomcat or a Wildfly servers in a simultaneously to all the servers, guys. Okay. And it will be working in terms of blue-green technique here. Okay. So this is one of the architecture. And if the organization is using the microservice architecture, then we will be using the containerization tool, that is Docker. All our application, the size of this Docker containers will be very less, guys, here. Okay, it will be in terms of MB only. Okay, if I want to give an example, if the Ubuntu operating system will be having approximately normal 15 to 20 GB, whereas if you are using this Docker, it will be within around 100 or 200 MB only. That's it, not more than that. Okay, because of this size will be very less, we'll be able to move this application from one location to another location. Location in the sense, not a physical location here, from Windows to Linux, Linux to Windows, or vice versa, or to the Mac OS. Okay. And even using this Docker also, we can perform the deployment to our application servers. Okay. So this is all about the architecture here. And being a human, cannot able to monitor our entire infra, whether it is working fine or no. So hence we will be using this monitoring tool like Prometheus or Grafana. So if anything goes wrong with our entire infrastructure, so this Prometheus or Grafana will send the notification to the supporting team member by using any one of the ticketing tool. Okay. Will assign a ticket to the concerned team member. Okay, if the issue is with the application side, so this team member will assign a ticket to developers here. If the issue is with the infrastructure side, then this he is going to assign a ticket to the in DevOps engineers, guys. Okay, so this entire process is called as a CI/CD process, guys. Okay, so any queries? Okay, so before that, let me add a syllabus what I'm going to teach. So from the VCS, I'm going to teach it, guys. Okay, it is every most of the organization they are using. Then Sonar Cube, okay. Then Maven, okay, for build tool. Then Nexus, okay. JFrog I am not using. Why? Because it is a paid one. Okay. So for only for 30 days it will be available. Hence I'm using Nexus, and some of the organization they are using Nexus as well. And even in my current project also I'm using Nexus. It depends actually. Okay. Both works fine. So then what else? Okay. Jenkins, CI tool, then Ansible. Okay. Then Docker, what else? Tomcat for application server. Okay, then Kubernetes for orchestration. Okay, there is an advanced version of Docker, guys. Okay, I mean on top of Docker, Kubernetes has developed. Okay, then Terraform. So Terraform will be used. What are the infrastructure I provision maintained here, right? So this all these things I will provision via code here. Okay, so for that we'll be using this Terraform here. Okay, and for monitoring we'll be using Grafana. So when it comes to the AWS, guys, okay, we'll be teaching on EC2 instance load balancer.
Grafana and Prometheus is both are same software.
Yes, I mean basically from Prometheus we'll get the data to Grafana here.
Prometheus company provides Grafana, you are telling, correct?
Agents are there. That is a node exporter agent is there. Okay, so that agent is responsible for flushing the metrics to the Prometheus. Okay. So, but Prometheus is not having a good UI here. Okay. So, hence, what we will do, we will use this Prometheus as a data source. Okay. And we will visualize it in the Grafana.
So, without using Prometheus, we can't use Grafana.
No, we cannot. So, auto scaling and VPC, that is a virtual private cloud, and storage. Let me know, guys. Okay. So, these are all the things. I mean, most importantly, I mentioned forgot here the Linux one. Okay, Linux is very basic. So like with the being a DevOps engineer, so we'll be working in Linux environment only. Okay. Hence Linux is must. So I'll be teaching Linux first, then I'll go with all the rest of the other tools.
What about the scripting language? To write CI/CD pipelines and all, we require a scripting language, right? Or that might be Bash or Python.
CI/CD tool, we are using the Jenkins here. So here we will be writing the Groovy script. So coming to the Ansible, here we will be working in a playbook here. Here we will be writing it in a YAML file. And here in a Kubernetes, again, it is in a YAML file only. Okay, here we used to write the manifest file. And then Terraform, here we'll be writing the HCL. Okay. So I'm just mentioning the basic things, guys. Okay, once, I mean, if I mention more, so you may feel uncomfort. Okay, hence I'm not mentioning everything. So all the tools is having their own commands, which we need to do the hands-on, guys. Okay, but most of the code you will get it in a Jenkins, Ansible, Docker, and Kubernetes. Sorry, and Terraform as well. Okay, here we will be writing the code here. Code in the sense, don't think that it is like a Java or C Sharp, something like that. Okay. Here we'll be writing it in a YAML file. So here you guys need to be familiar with how to write the YAML file here. Okay. Some basic restrictions are there. So once you're familiar with either with YAML, so then it will be very easy. Okay. Even with the Terraform, sorry, not Terraform, Kubernetes, Ansible, and Docker as well.